Manufacturing a photolithography machine, especially advanced ones used for semiconductor manufacturing, is an extremely complex and difficult task due to several key factors: precision and complexity of the technology. Extreme precision photolithography involves creating intricate patterns on semiconductor wafers by shining light through masks. To produce chips with smaller transistors, e.g. 5 nm or 3 nm processes, photolithography machines must achieve incredibly high levels of precision. The patterns need to be aligned and etched with nanometer-level accuracy. This requires ultra-precise optical systems, stage positioning, and alignment mechanisms. Deep ultraviolet DUV and extreme ultraviolet EUV light. To print smaller features, photolithography machines use light with wavelengths as short as 13.5 nanometers EUV. Creating such short wavelength light requires highly specialized equipment and techniques, as typical optics and lenses cannot focus light this small. EUV lithography, in particular, requires mirrors coated with multi-layered films to reflect light, adding to the difficulty of the manufacturing process. High-quality materials. The components of photolithography machines, including lenses, mirrors, and light sources, must be made from extremely high-quality materials. For example, EUV machines rely on specialized mirrors with very fine coatings, which are extremely difficult to produce and maintain. Vacuum environment. EUV machines need to operate in a vacuum to prevent the absorption of light by air. Creating and maintaining this vacuum environment is challenging and requires highly advanced materials and systems. Engineering challenges. Thermal management. The light sources, particularly those used in EUV lithography, generate immense amounts of heat. Managing this heat is critical, as overheating can damage delicate components and distort the precision of the system. Alignment and calibration. Photolithography machines require continuous alignment and calibration to ensure that the printed patterns are accurate. As technology advances, the degree of alignment required becomes more difficult to achieve. The machines must be able to align not just the photomasks, but also account for the physical distortions that happen at such small scales. Massive R&D costs. The development of photolithography machines, especially advanced ones like EUV, involves enormous research and development costs. Companies like ASML, the leader in this field, invest billions of dollars over several years just to develop and refine a single machine. This includes extensive testing, innovation in optics, light sources, and motion control systems, all of which require a team of highly specialized engineers and scientists. Long development cycle. Developing these machines takes years, not only because of the complexity of the technology itself, but also due to the need for constant testing and refinement. Moreover, these machines must be reliable over many years of continuous operation in semiconductor fabs, adding another layer of challenge. Supply chain and manufacturing complexity. Sourcing high-precision components, photolithography machines require components from a wide range of specialized suppliers, many of whom produce highly advanced and custom-designed parts. The supply chain for these machines is intricate and highly specialized. For example, ASML depends on suppliers for high-precision optics, vacuum technology, and light sources, all of which must meet extremely strict quality standards. Integration and assembly. The final assembly of photolithography machines is a highly delicate process, requiring tight integration of various subsystems. Any misalignment or flaw during assembly can have serious consequences for the machine's performance. High cost. The cost of manufacturing photolithography machines can reach hundreds of millions of dollars. The technology is so advanced and specialized that each machine is effectively custom-built. This makes the machines extremely expensive and only feasible for a few companies to produce and maintain. Scaling challenges. Even once a photolithography machine is developed, scaling production to meet global demand for semiconductor manufacturing is difficult. The machines are so complex that producing multiple units quickly is not feasible. Conclusion. Manufacturing photolithography machines is difficult because of the extreme precision required, the specialized materials and components, the engineering challenges in aligning and cooling the system, the massive R&D investment needed, and the intricate supply chain and assembly processes. Only a few companies, such as ASML, have the necessary expertise, technology, and resources to produce these machines, making it one of the most advanced and specialized fields in modern manufacturing.